All right, let's go over the midterm study guide, the midterm review assignment. The midterm will be based on chapters 2 through 8, and I basically have it set up so that everything will go in order of how we did it, starting with chapter 2 and ending with chapter 8. So, let's see. Number 1, in the past 5 years, do you think that things have gotten worse, stayed the same, or gotten better? The possible responses were worse, no change, better, don't know, and no response. What kind of variable is this response? Remember, a quantitative variable or quantitative data is data that is measured. Quantitative sounds like quantity. Categorical data or a categorical variable is data that falls into categories. In this case, the data is not measured; it falls into categories: worse, no change, better, so on and so forth. So this would be a categorical variable. Number 2, the researchers measure how many seconds it takes for half of the substance to exit the bloodstream. The key word is the researchers measure. Okay. So because the data is measured, that makes this a quantitative variable. Number 3, what percent of all applicants were Asian? So what percent of all applicants were Asian? So out of all the applicants, the 1,280, okay, how many of them were Asian? 422. So we want to calculate 422 out of 1,280. Okay, and it says to round to one decimal place, but we want to convert it to a percent first. So this is going to be 32. No, it's actually going to be 33.0% if we round it. Okay. Part B. What percent of the students accepted were Asian? So out of the students who were accepted, so there were 191 that were accepted, 62 of them were Asian. So it's going to be 62 out of 191. So that would be 32.5%. What percent of Asians were accepted? So out of all of the Asians, so there were 422 Asians, how many were accepted? 62. So it will be 62 out of 422. So that will be 14.7% if we round it. Okay. D, what percent of all students were accepted? So how many total students were there? There were 1,280. Out of the 1,280, how many were accepted? 191. So 191 out of 1,280 were accepted. So that's going to be 14.9% if I round it to one decimal place. Okay. So that is it for number 3. Number 4, we're going to do the same thing, except notice that the totals aren't given. So just a little trick you can use. If you, instead of writing it down, you could certainly write it down if that's easier for you. But if you would prefer not to write it down, if I click on this up here and then go to, open in StatCrunch. So again, click on this thing up here and then click on open in StatCrunch. Okay, it gives us this. And it has the data in a spreadsheet. So then what I'm going to do is I'm going to take my calculator and I'm going to quickly as I can, total everything out here. So bear with me for a moment. And this will make it a little easier to go ahead and solve all of the parts here. Okay, so I totaled this out. So it's the first one. What percent of the graduates are white? So out of the total 362 graduates, how many of them are white? 288. So we need to do 288 out of 362. So 288 out of 362. Round to one decimal place. So that's going to be 79.6%. So 79.6%. What percent of the graduates are planning to attend a 2-year college? So again, out of the 362 total graduates, how many of them are planning to attend a 2-year college? 50. So 50 out of 362. So that will be 13.8, right? 13.8, yep. So 13.8%. What percent of the graduates are white and planning to attend a 2-year college? So again, out of the 362 total graduates, how many of them, and this is the key, are white and going to a 2-year college? That's this one right here. These 40 are white and planning to attend a 2-year college. So that's 40 out of 362. So that would be 11.0, 11%, essentially. What percent of the white graduates are planning to attend a 2-year college? So let's go back to the data set here. So out of the white graduates, so out of the 288 white graduates, how many of those white graduates are planning to attend a 2-year college? 40. So 40 out of 288. So that would be 13.9%. Okay. What percent of the graduates planning to attend a 2-year college are white? So out of the graduates who are going to a 2-year college, so out of those 50, how many of those 50 are white? 40 out of 50. So now we're going to do 40 out of 50. So that's going to be 80%. And that's it. Describe the shape of the distribution. Is the histogram uniform, unimodal, or bimodal? So uniform would mean that the histogram it is at the same level or close to the same level throughout. This clearly does not happen. So it's either unimodal or bimodal. In this case, it's going to be unimodal because it has one mode. It has one high point up here. So this is going to be a unimodal histogram. Is the histogram symmetric, skewed to the left, or skewed to the right? Okay. We know what symmetric means. There's clearly no symmetrical nature here. So it's either skewed left or skewed right. The direction that it's skewed is the same as the direction that it tails off in. In this case, the histogram tails off to the left-hand side. So we're going to say that this is a skewed left histogram. Describe any unusual features. So unusual features means, are there any gaps and are there any outliers? In this case, there are neither of those. If there are no gaps and no outliers, that means there are no unusual features. And the choice that says that, therefore there are no unusual features, is B. Okay, number 6. Let's see. What is the mean of the entire data set? All right, so the first thing we want to do is we want to open a spreadsheet on Google Sheets. So if you open your Google Drive and you go to New and you click on Google Sheets, you'll open up a blank spreadsheet. Okay, and on here, on Math Excel, you're going to click on this thing right here. And you're going to click on Copy to Clipboard, which is this thing here. Okay, and notice it has all the data highlighted. So I'm on my keyboard, I'm going to hit Control C. And then I'm going to go to my Google spreadsheet, and I'm going to, on my keyboard, hit Control V. And it has now, it copy and pasted the data into the spreadsheet here. So to find the mean of the entire data set, I'm going to type in equals average. Remember, average is the same as the mean. And I'll select average. And then I'm going to highlight the data. Highlight all the data with the touchpad or the mouse, whatever you're using. And hit enter. So this is the mean of the entire data set. So rounded to 2 decimal places is going to be 2.30, $2.30. Okay. What is the standard deviation of the entire data set? Okay, I'm going to type equals stdev. Equals stdev. So I will choose standard deviation and once again highlight the data and hit enter. Notice it says to round to 3 decimal places this time. So that's going to be 0.084. What is the mean of the entire data set with the 2 highest prices removed? So first of all, what are the 2 highest prices here? Let's see, 247 would be the highest, and it looks like the second highest would be 249 is the highest, and 247 is the second highest. Am I correct in that? I don't see anything higher than 249. I don't see a 2, yes. So these two, 249 and 247, are the highest. And notice, let me label this here. Notice if I go here and I remove the 249, so I'm going to delete that, and then I'm going to delete the 247. Notice it automatically adjusts. So the mean of the data set with the 2 highest prices removed is going to be $2.28. And then standard deviation rounded to 3 decimal places is going to be 0.052. Okay. Choose the correct comparison below. So let's see here. Notice the mean went from 230 to 228. So the mean of the entire data set is 2 cents greater than the mean with the 2 high prices removed. So it's 2 cents greater. So what that means, let's see which choice says that. The mean of the full data set is about 2 cents greater. So that takes us to either A or D, because both of those say the mean of the full data set is about 2 cents greater. Okay, let's see. Here we go from 0.084 to 0.052. So again, the standard deviation of the entire data set is also greater. So is that which one says that, A or D? Standard deviation of the full data set is about 3.2 cents greater. That means the answer is going to be A. Let's continue. Okay. A wholesale food club charges all users a basic monthly fee and then adds on extra charges based on usage and other services, resulting in different fees for various users. They compile data recording each user's bill. Suppose they raise the basic fee by $3 a month. Which of these statistics in each group will stay the same? Which will change and how? So we're going the min, the max, and the range. Remember, the range is the difference between the max and the min. So the key is we're changing the initial fee, the monthly fee. We're changing that by $3, which means everyone's bill is going to go up by $3. So if everyone's bill is going up by $3, that means the min and the max are both going to go up by $3. Okay, so we know that min and max will go up by $3. But how spread out the difference between the min and the max, how spread out they are not going to change because they're both going up by the same amount. So the min and the max will both go up by $3, but because they're both going up by the same amount, that means the difference is not going to change. Okay, which means the range will not change. Okay, so let's see which one makes most sense here. The min and the max will not change. Nope. The min will increase. The max will nope. Both the min and the max will increase by the same amount, which means the difference between them will not change, and therefore the range will not change. So that's C. Okay, now this time, what are we doing? Suppose they raise their rates by 15% for everything. Basic fees, usage charges, and other services. How will that increase each of these statistics summarizing customers' monthly bills? So the key with this one is that everything is going up by 15%. It's not going up by a set amount. So 15% of the min is going to be a lot different than 15% of the max. All right, so the max is going to increase by a higher amount than the min will. Okay, so because of that, they will increase, but they're not going to increase by the same amount. And if they're not going to increase by the same amount, that means the difference is going to change. So both the min and max will increase, but they will not increase by the same amount. B, this means that their difference will change, causing the range to change. That is true. A set of data items is normally distributed with a mean of 270 and a standard deviation of 36. Convert 126 to a z-score. So, converted to a z-score. So if you forgot and you need to look in chapter 6, look in your notes from chapter 6. To find the z-score, we take the data item, which in this case is 126, and we subtract the mean. So that's going to be subtract 270. Right, we get an answer of negative 144, and then we're going to divide that by the standard deviation. Okay. So my z-score is negative 4. In this case, that is how we find the z-score. Okay. Now, let's see, different numbers. Now we're going to convert 43 to a z-score. So I'm going to take 43, the data item. I'm going to subtract the mean. So in this case, the mean is 40. The difference of 3, and then I'm going to divide that by the standard deviation of 6. So I have a z-score of 0.5. Okay. Set of data items normally distributed. Find the data item in this distribution that corresponds to the given z-score of 9. So now we're going to go from a z-score, and now we want to find the data item. Okay, so now we're going to go backwards. Okay, we're instead of going from a data item to a z-score, we're going to go from a z-score to a data item. So when we're going backwards, instead of subtracting the mean and dividing by the standard deviation, we're going to multiply by the standard deviation and add the mean. So we do the opposite operations in the opposite order. So I'm going to take the z-score of 9. I'm going to multiply it by the standard deviation. Okay. And then I'm going to take that and I'm going to add the mean. So 970. Okay, livestock company reports that the mean weight of a group of young steers is 1,076 pounds with a standard deviation of 84. Based on the model for the weights of steers, what percent of steers weigh over 1,250 pounds? So to do that, we're going to go into StatCrunch. So if you forgot, you go to statcrunch.com and you're going to log on using the same username and password as Math Excel, and you're going to click on Open StatCrunch. And it opens a spreadsheet here. And to answer this question, we're going to go to Stat, Calculators, and Normal. So again, that's Stat, Calculators, and Normal. Okay, so I'm going to put in the mean, which was 1,076, and I'm going to put in the standard deviation of 84, and I want to know what percent of the steers weigh over 1,250 pounds. So I'm going to change this to greater than because it's over 1,250 pounds. I get that answer, and I'm going to notice I need the answer as a percent. I need to round it to 1 decimal place. So that's going to be 1.9%. Now we want the percent that have a weight below 950. So same mean, same standard deviation. I'm going to change this to less than, and we want it to be less than 950. That's going to be 6.7%. All right. What percent of the steers weigh between 1,200 and 1,300? So to do that one, we're going to go and click on, we're going to go here, and we're going to click on between. Same mean, same standard deviation. We want the mean to be between 1,200 and 1,300 pounds. And there's our answer. So that's going to be 6.6%. Okay, and that is it for that question. Okay. Let's see. Based on the model here describing steer weights, what are the cutoff values for this? So first of all, we're going to use the same thing on StatCrunch. This first number, the 1156, that is the mean. And then the 88 is the standard deviation. Okay, and now we want the lowest 10%. So this time we're going backwards. So because we're going backwards, first of all, we want highest. So I'm going to change this to greater than because I want highest. And because I'm going backwards, I'm going to go after the equal sign and I'm going to put 10% as a decimal. So 0.10. So this right here is how I'm going to do part A. And when I hit compute, I have an answer here and I'm going to round it to one decimal place. So 1268.8. Now we want the lowest 20%. So again, same mean, same standard deviation. Now I'm going to change this to less than because of lowest. And then after the equal sign, I'm going to put 20% as a decimal. So this will give me 1081.9. Now we want the cutoff for the middle 40%. So because it's the middle, now we're going to go up here. We're going to go to between, click on between. Okay, same mean, same standard deviation. Let's, clear this out. Same mean, standard deviation. We want the middle 40%. So I'm going to put 0.40 after the equal sign. And then it gives me the two answers. So that will be 1,109.9 and then 1,202.1. All right, and that is it for number 14. Or excuse me, number 13. Number 14, let's see, which is which? Match each scatter plot with its calculated correlation. So this is what we did the most recently. Okay, so remember, so when I look at this, notice I look at the scatter plot and I notice that there are two clearly positive scatter plots and I see two positive correlations. So when I look at these scatter plots, B and C, which one is stronger? Okay, to me, B is the stronger one. The dots are more tightly clustered. Because B is the stronger one, B's correlation is going to be closer to 1. So B is going to be 0.951. And then the other positive will automatically go to C. So that will be 0.736. Okay. So I've gotten B and C. When I look at A, notice A, there's not really a pattern there. It just kind of looks like a bunch of random dots. So whenever it looks like a random pattern, or if the pattern is nonlinear, that means its correlation is going to be closest to 0. So if the correlation looks like a bunch of random dots, or if the pattern is nonlinear, its correlation will be closest to 0. So in this case, the one that's closest to 0 would be negative 0.021. So that will go with A. And then by process of elimination, the only one we haven't used is this one right here, negative 0.923. That's going to go with D. And that should be the answer for number 14. Okay. Okay, so make a scatter plot for the data. All right, so first thing I'm going to do here is I'm going to click on Open in StatCrunch. So if you missed that, I clicked up here and I clicked on Open in StatCrunch. And we have our data here. So to do our scatter plot, okay, to generate a scatter plot, you click on Graph, and then you go to obviously scatter plot. So again, that's Graph and scatter plot. My X variable, my first column, okay, is fat. And my second column is calories. And let's click on compute here. And we get this one here. Okay. So this one, it looks like a positive one for me. So that takes out B and C. Okay. And let's see. This one looks like it's closer to 650. So I'm going to go with D. But I would accept A as an answer, but I believe this one, yep, this one is D. What is the correlation coefficient for the data? So to do the correlation coefficient, I'm going to go to stat, summary stats, and correlation. So stat, summary stat, and correlation. And I'm just going to make sure, and you may need to hit, or you may need to hold the control button on your keyboard down. So you want to make sure you select both. And it tells us the correlation, which is, if we round it to the nearest thousandth, means 3 decimal places. So that's 0.892. Which of the following best describes the association between the fat and the calories? So we have our scatter plot, which is linear. Our correlation is pretty high. So we have a high correlation. So that narrows us down to B and C. And we already said it's a positive one. So the answer in this case is going to be C. Scatter plot and high correlation coefficients suggest a strong positive linear relation. Okay, 16. Let's see, we'll do the same thing. So we'll click here and we'll click on open in StatCrunch. Okay, so this is the one about the price, age, and the price of a car. All right, and we're going to do a scatter plot. So graph and then scatter plot. So age and price and compute. So let's see here. So it looks like these top two here are by 14,000. So I'm going to say the answer here is C. Okay. Find the equation. Okay, let's X that out. Find the equation of the regression line. So to do that, we're going to go to stat, regression, and simple linear. So stat, regression, and simple linear. And again, we'll choose age and price. And we'll look at the fourth line down, 1, 2, 3, 4. So if I fill in, that's going to be 14, so let's see, round to the nearest integer. So that'll be 14,271, and then negative 955. Does a linear model appear to be appropriate? So, in other words, is the scatter plot reasonably straight? And the answer is yes. The scatter plot is reasonably straight and there are no outliers. Explain the meaning of the slope of the line. The slope, remember, is the number that is attached to the x variable. It's the x variable coefficient. So in this case, that's the negative 955. So the fact that it's negative tells me that the value of the car is decreasing as it gets older. Okay, so a car's average value decreases as it ages. Okay, the other number, the 14,000 number, that is your y-intercept. And remember, the y-intercept is the value of y when x is 0. In this case, x is age. So the y-intercept is going to be the cost when the age of the car is 0. When the age of the car is 0, that means it's new. It's the average cost of a new car. You have a chance to buy one of two cars. They are about the same age and appear in equally good condition. Would you rather buy the one with a positive residual or the one with a negative residual? All right, so if you forgot what a residual is, the residual is the difference between what actually or what is what actually happens minus the one minus our prediction. So the residual is the difference between what actually happened and what we thought would happen. So if we have a positive residual would mean that the actual value of the car was higher than what we thought it would be. And the negative residual would be that the value of the car is less than what we thought it would be. Okay, so that actually answers the next one. The one with a negative residual costs less than the model's predicted value, and the one with a positive residual costs more than the model's predicted value, costs more than the model's predicted value. So the question is, assuming they're in good condition, do I want to pay more or do I want to pay less? Obviously, I want to pay less. So I would rather buy the one with the negative residual. Okay. Would this regression model be useful in establishing a fair price for a 21-year-old car? So this is our model up here. If I were to plug in 21 for age, okay, you could probably guess if I plug in 21 for age, that would predict a negative value for a car. So the answer in this case would be no. The model predicts a negative price, which does not make sense. Okay. And that is it for your midterm review assignment. Obviously, make sure you reach out to me if you have any questions.